around I think 5 years dah lama saya tinggalkannya. Okay, so I don't have the current example, and then I need to prepare a lot about that topic. So maybe later I will share with you, because there is very beautiful topic, and then still okay, and still can be explore, all right, among us. And then one of the top researcher in Indonesia, you can find out that I cannot remember the real name, but you can search Si Tungkir. Okay, he has a lot of paper related to social network, but network analysis, but they apply more on sociology. All right, so maybe you will be benefit more. Then you can see how beautiful is statistics, how beautiful is mathematics in creating something, the good finding for us. Okay, so after that I said, okay, why not I share with you about the outliers, because outlier, okay, is something very good topic if you want to go further. If you want to go further, what do I mean is for your final year project. Do you have a final year project? By the end of the maybe third year, 3 years or 4 years, your program? 3 or 4?
4 years.
4 years, okay. Maybe in the 4th years, you have to come up with a proposal, then you have to come up with some idea. Okay, outlier will be one of the topic that you can explore more. Okay, and then the same thing, maybe you can extend that particular research into more deep, and then you can be a master student, and then more deeply you can extend into PhD level. So from the outlier topic, it can be degree level, master level, PhD level. Okay, but don't make you under stressful and depressed. That would be another level, right? So that's why today I choose the topic of outlier, so that you can explore and explore. That is one topic in statistic. Okay, it doesn't mean that only thing that we have in statistic. All right, I've already shared this material with Pak Wanda. Okay, you can get this material from maybe Dr. Ibu Mariza can share. Okay, right. So, all right. So I'm working in Pusat Pengajian Sains Kuantitatif, School of Quantitative Science. So among me is statistician, mathematician, and decision scientist. Decision scientist more to operational research. Okay, under our school. So you can go through my profile, via Google Scholar and ResearchGate. I'm not really good in publication, but I have some publication that maybe you interest on that. Okay, you can read and contact me later. All right. So I'm working in University Utara Malaysia. University Utara Malaysia is located in the northern part of Malaysia, very close to Thailand. We are about, I think, 30 kilometers to 40 minutes to Hat Nyai, to Phuket another part, but to go to the Hat Nyai is very close to us. But I've never been there, I think more than 10 years. All right, even very close, never been there. Okay, so the outlier topic. All right, so what is outlier? Do you know about what outlier? Have you learned already the topic outlier somewhere? Maybe in inferential statistic, maybe in multivariate statistic, or maybe under the topic of some sorts of data screening, maybe under the topic of exploratory data analysis. I'm not sure, but somewhere there. Have you learned before? Can you put it in the chat room? Have you? Or you can put some icon. You can use any icon to show that you already know a little bit. At least you know the word outlier before this.
Ayo, untuk para peserta, apakah sudah pernah belajar pencilan atau outlier?
Sudah belum?
Saya yakin ini di mata kuliah
jika pernah dengar
pasti dapat. Ayo di chat aja nggak apa-apa, saya sudah pernah gitu. Di chat juga nggak masalah ya. Ataupun bisa di chat atau misalnya
Icon, you can use
icon,
it.
ya, reaction.
No. All right.
Wah,
So,
ini. Oke, silakan.
All right. Okay, don't worry. Okay, a person or thing or fact that is very different from others, that is outlier. Okay, if you sit down within your friends, okay, let's say 4 of your friends, okay, among you, when you talk about some opinion, okay, one of them maybe give different opinion, very different, that is also, we call it outlier. All right, but cannot be measured lah. All right, it cannot be measured, but what the mean by outlier is something very different. All right, so we can call it anomaly or abnormal value. So of course, in statistics, we're looking into the numbers that are very far from the others. The numbers are very extreme to the others. The number that are maybe very large, maybe very small, doesn't matter. It can be small number, it can be large number. But how large is large? How small is small number? All right. So a univariate outlier is a data point that consists of an extreme or unusual value on one variable only. Okay, let's say you as a student, you have the marks, okay, the performance on mathematics subject, on algebra subject, maybe on what kinds of subject, algebra, mathematics, statistics, English subjects, all right? So you consider one by one. You're just looking into mathematics subject. What is the outlier? You're looking into English subject. Which one is the outlier? You're looking into one by one. The variable one by one, that's what we call a univariate outlier. All right. Another one is a multivariate outlier. It's a combination of extreme or unusual value on at least 2 variables. So we consider several variables in one time. Then we look at among these 2 variables, which one become outlier, the observation. Okay. So let me show you the idea of outlier. This is only the analogy, all right? This is only the analogy, all right? So I crop these maps, okay? So I crop this map and then I put a circle. Assume the circle is the control limit, all right? Any location outside the circle, I consider is as outlier. Okay, so in this case, ITB is here. Where is that? Bandung Institute of Technology is here. So it's become outlier because it's going outside of the circle. All right, when we look at into one variable, when we look at into several variables together, so you look at this. Oh, okay. Wait, okay. You look at into this circle as a whole, then ITB not the outlier. So that's what do I mean by when we consider one only variable and we consider a multivariate variable. So for me, I would suggest to practitioner, okay, because I involve a lot with consultation, okay, I do a lot of workshop to non-statistician practitioner, to non-statistician researcher, to the PhD postgraduate students, okay? So I will differentiate to them, okay, about the univariate outlier, and this is, I say, the analogy only, okay? The multivariate outlier. When we look at into more complex, all right, when we look at into, we consider more variable in one time, now ITB not the outlier. So that is the analogy why we have to consider multivariate outlier instead of univariate outlier. All right, but with condition that the variable are interrelated. The variable should be interrelated. Is what example? Let's say you want to study about poverty. All right, you want to study about poverty among Asian countries. Okay, poverty among Asian countries. So maybe you will look at into GDP, gross domestic percentage. Maybe you will look at into unemployment rate. Okay, so maybe you will look at what kinds economics indicator. So these variable should be related first. Then you can consider by checking multivariate outlier instead of univariate. You get the idea of univariate and multivariate? Okay. All right. So that is the difference between multivariate and univariate outlier. Okay. So the outlier exists for 4 reasons, maybe more reasons. Okay, but I list down for 4 reasons here. First is about incorrect data entry. Can cause data to contain extreme outlier. So incorrect data entry, you have to improve the way you enter the data. Okay, maybe if you use survey, nowadays we will use a Google form, right? No more to key in the data. So of course you can avoid incorrect data entry. But sometimes for those who are using experiment, for those who are using observation, maybe you use a secondary data where you have to key in manually into the computer, into the database. So it may be incorrect. So the first one, it may come from this source. Okay. So every time when you key in the data, ensure that the data is correctly entered to avoid the outlier. Okay. Second, failure to indicate code for missing value in dataset. So usually we will use a large number 999, okay, for to indicate the missing value. When you have a missing value, let's say you use SPSS, you have to put some value to replace missing value, okay? Because the computer, when they see the blank, okay, without any value, they assume that you missed the value. But actually, the value is no value. Then you have to put 999. So maybe when you put 999, you didn't declare that that is the label for missing value. So that also will detect as outlier. Okay. So third one, the case didn't come from the intent sample. So let's say you want to study about the children, okay, for the age around 10 years old to 15 years old, for example. But suddenly when you check their age, the age is 6 years old or maybe 25 years old. Okay, that is also outlier. So you have to be specific to those that will be your sample. You got my point? All right. So number 4, the distribution of the sample for specific variable may have a more extreme distribution than normal. All right. So the outlier can come exist for 4 reasons and maybe more. All right. So why we want to consider? Why do we want to study about the outlier? Because the outlier have negative effect. Because the outlier will give us bad impact to the calculation, especially. I will show you the calculation of something about t-test after this Cronschbach alpha, and then the effect when the outlier inside the data. Okay. So effect of outlier, they will increase the variability in our data, which decrease the statistical power. So our statistic will be not powerful. Okay, so it can skew our data distribution. Okay, because the outlier usually, okay, they will affect the mean, the average. Okay, mean is a good measure to use to describe data that are close in value. Okay, the median more accurate describe data with an outlier. If your data having an outlier, okay, if you know that your data have outlier, then you use the mean. It will spoil. Okay, your calculation will be wrong. If you calculate the correlation will be wrong because the correlation also depends on the mean value. If you calculate the variance and covariance metric also will be wrong because variance and covariance effect by the mean value. So anything, the formula involved with mean, if you have the data outlier in your data, so the calculation will be misleading. Okay, so that is the weakness of outlier in the data set when we use mean or mean formulation. Okay, so instead of mean, okay, if you want to remain the outlier, doesn't matter. Okay, but you have to choose median instead of mean, because median is more accurate in analysis. Okay, the mode is good measure to use when we have a categorical data. Okay, so let me show you the effect in terms of outlier. Right? Sorry for taking a time, right? Okay, I show you the Excel file. Okay. Again, sorry. Okay, now is the Excel file. Can you see? Okay. I will make it a little bit large. All right. So, okay, assume 29 become the outlier. I put the yellow color. All right. So I remove this 29 from the sets of the data. So to the left. Okay. So the right side, sorry, to the left, to the right. Okay, the right side is the data without outlier. The left side is the data with outlier. Okay, so we can see the difference in terms of mean. All right, with outlier, the mean value is 58.63. Without outlier is 62. You can see the difference, right? And then the median also different. The standard deviation is far different. Instead of 14, now very small, right? So without outlier, the standard deviation very small compared to when we're having the outlier, the standard deviation is, SD is standard deviation. Okay, so 14.5.2 is large. So tendency of standard deviation to be large is high when the data involved with outlier. Okay, so anything in the formula, let's say t-test in the formula using mean and standard deviation, right? ANOVA, analysis of variance, also involved with mean and standard deviation. So everything related to parametric statistics, independent sample t-test, paired sample t-test, analysis of variance, analysis of covariance, what else? Okay, will be effect if the data involved with outlier. So that will be your research problems. Okay, you can say, okay, independent sample t-test is widely used by this one and this guy and blah, 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 the benefit of independent sample t-test. However, okay, if there is outlier in the data set, okay, the computational of independent sample t-test, the computational of ANOVA will be misleading, will be wrong. Then how to solve the problem when the data having the outlier? All right, so that's what do I want to explain to you in the middle of the slide. Okay, so it's also will affect, okay, let's say here, okay, I put a correlation. Okay, correlation value also will change. T-test also will affect. For those who are using multiple linear regression, the R-square is the most important measurement, also will be affected. So the value is affected by the outlier. Okay, Very clear the effect of outlier in the calculation. Okay, you can try by using just Excel, then you can see the different data with and without outlier. Okay. All right. Now, how to detect the outlier using statistics? Okay. In univariate statistic, we can use it. What we call here is Z score. All right. You standardize the score of the data. All right. By let's say you have a point of data, then you standardize. The value should be between 3.3. So the data is not outlier. If the value is outside 3.3, or the left side, either to be the left value or the right value, anything more than 3.3 or anything less than negative 3.3, that is considered as outlier. So we have to remove the outlier from the data set. Okay. Or maybe you want to use another method by using box plot. Okay, the same thing. The idea is that we have the benchmark, we have the cut-off point, we have the limit, the right side and the left side, the minimum value, the maximum value. Any value that outside the maximum area, that is considered as outlier. Okay, on the left side of minimum value is also outlier. Okay. Okay, in multivariate outlier, so how to detect multivariate outlier? There are so many ways in detecting a multivariate outlier. One of that is Mahalana Resistant. Okay, I just introduced here a Mahalana Resistant. Okay, but the issue of Mahalana Resistant, there are several issues. Two of that I highlighted here. Okay, first is Mahalana Resistant sensitive to outlier. Okay, that is sensitive to the outlier. If the data, the outlier present in the data, they can have an large impact on the calculation of the covariance metric, which in turn affect the calculation of Mahalana Resistant. All right, and then the second one is computational complexity. Okay, do you know the formula of Mahalana Resistant? It's similar to Hotelling T squared. It's similar to Hotelling T squared. Okay, the formula, where inside the formula, they have the inversion of covariance metric. Okay, you have to calculate the covariance metric. After that, you have to find out the inverse. Apa ya, metric songsang ya. Okay, kalau in Malay we call it metric songsang. I'm not sure in Indonesian language the inversion of the covariance metric. So that inversion of covariance metric is not will be not exist if the determinant of covariance is singular. Okay, that is my area of study, and even Pak Wanda also play around with this one, computational complexity of the Mahalana Resistant. So when the inversion of the covariance matrix cannot be computed, right? So we cannot perform Mahalana Resistant. So that is the issue maybe for master level and PhD level. So how to solve Mahalana Resistant? Okay, what is the alternative way to Mahalana Resistant when we face with this problem? Okay, all right. So these two, what we call issue that I highlight here, can be a postgraduate project. Even for undergraduate project also can be done, right? Can be done, but of course lah, some limitation compared to postgraduate, because they have a long journey, they have a long process, so they can study more and more, especially in algebra, because Mahalana Resistant is multivariate. When we involve with multivariate, we have to be strong with strong knowledge in algebra. Okay, mathematics and statistics cannot be split. We have to work together, but that is the challenging lah, the challenging. All right. So now outlier. to be removed or to be remain or to be imputed. Okay, before this I said after detecting the outlier, we want to remove it. Okay, we remove the outlier. But sometimes people said we have to remain. Okay, we have to remain the outlier. Why we have to remain the outlier? Because the data is expensive. It's not easy to get the data. The data is correct. Nothing wrong with the data. The outlier is outlier. We have to perform the outlier. So if you have that kind of perception, you have to remain the data. But how? Okay, but how to use the Mahalana Resistant? How to use the existing method that don't want the outlier inside the data? That would be another issue in statistic, where you can use robust statistic and non-parametric statistic. Okay, when we want to remain the outlier inside the data. All right. The third one, maybe you want to impute. Okay, for certain analysis, let's say exploratory factor analysis. Exploratory factor analysis. Apa ya? Faktor analisis penjelajahan ya. Exploratory factor analysis. The minimum, most of literature, okay, most of researchers say the minimum sample size to conduct EFA, exploratory factor analysis, is 100 samples. So let's say from 100 samples, then you detect 10 outlier. Means that if you choose to remove, the data remain only 90. Right? You ada 100, and then you tahu 10 itu outlier, you buang. Maka yang berbaki itu cuma 90. Alright? So since the available data is only 90, it cannot fulfill the requirement of EFA. Alright? You cannot fulfill the requirement of EFA. Then that's why we have to impute. So outliers, sometimes we can just remove, sometimes we can remain, sometimes we can impute. All right. So what is the flower here? So in the middle is the flower without outlier, or the pink color outlier, very beautiful. All right. And then the left side, which one the outlier among these? We have the pink color, we have the red color, we have the white color, the orange color. It seems that the yellow is the outlier, isn't it? Okay, so the right side, all white, only 2 red color. 2 red is outlier. But even this one is look like outlier, but it's suit, right? It's match. Cantik sahaja banget, nampak? Alright, so here, even this one is yellow, it doesn't okay for me. So if you said the outlier should be remain, so we go to robust statistic and non-parametric statistic. Okay, it's not always if outlier remove. You don't have alternative way. You still can remain, you still can impute, but you have to go to another way lah. Instead of using a federal road, you can use a highway. Okay. So this is the topic in robust statistic. One branch of statistic is robust statistic, where it's robust in so many computational. So, okay. So I shared with you the pioneer, I think the pioneer of person who decide, who are talking, start talking about the robust. You can read from this paper, all right? They said the most highly cited is Huber, and its second edition Huber. The others is citation order are Russo, Hempel, Marona, and Hoglin. So all of these researcher is the pioneer in robust statistic. If you want to know more and more, you have to start from them. Okay, then you can see who cited their paper. You can see who cited their paper, then you can see the circle of robust statistic people. Okay, I'm also now working in robust statistic. Okay, because for me, robust statistic less challenging compared to high dimensional. Okay, but during my PhD work, this is my computational complexity is my aim. All right, my study is about computational complexity. What happened when the determinant of covariance is singular? Okay, so that is what be my problem statement lah. Okay, but nowadays I go into robust statistic because that's less challenging. Okay, and then one of my students, PhD student, already graduated. Okay, I asked him to merge these two topics. So I said, what happened? What happened if that statistic have that two problems? Okay, where the data inside the data is outlier and then the computational is complex. So these two can be merged together, become another level of PhD work. Okay, you can see. So that is the beauty of research. You can try only robust statistic, you can study about complexity, then you can try both to be together and see what happened to your statistic. Okay, statistics such as hoteling t-squared, weak lambda. My focus is on multivariate, but I can see from univariate side as well. Okay, for those who are try to find out for ANOVA, for independent separate test. Okay, there are so, if you Google, there are so many things that we can use for our research. That's overall is about outlier. Okay, and then this is about another paper that very important. So I share with you six papers that must be read. Okay, at least you can, even you cannot understand one by one, word by word, doesn't matter. Okay, because you are just undergraduate student, right? Doesn't matter. They don't push ourselves to understand word by word in first time. Okay, because my professor Maman Jawahari, okay, from Indonesia, okay, also supervisor to Pak Wanda. Okay, he said that statistics and mathematics sometimes need a time to be understand. So for me, sometimes we need a maturity. During my study in 2010, I still cannot imagine what do I want to do. Okay, but after 10 years now, 13 years already, 2023, 13 years, then I can imagine the connecting between robust, between high dimension. Okay, so slowly and steadily. Don't worry if you cannot understand now, but at least you have some info in your mind about the outlier. Okay, don't push yourself to understand what do I say today 100%. Biasa itu. Okay, perlahan-lahan, slowly. All right, so these three paper, fourth paper is among the citation, high citation paper. All right, this is my work with very simple work with my student. This is master student. Nuraimi Ruslan is master student. Tariq is my PhD student. All right, we calculate the type 1 error rate. We compare the classical and modified box M. Okay, box M statistic is for testing the equality of covariance. Okay, the original one, but the original one is sensitive to the outlier because in covariance, of course lah, covariance very dominant by outlier because inside the covariance, the calculation involved is mean. If you still remember mean. So I replace the mean by using M estimator and S estimator, M estimator, and MM estimator, right? So, and then I try to calculate the type 1 error rate. Okay, so which one would be better? Okay, so in summary, M can be used for testing the equality of two different covariance matrix or more than the data contain the outlier. So this is another one, another paper that I write with Alu. Alu is my PhD student. Okay, we modified the M statistic, but this one we using geometric median. Okay, we replace the geometric median instead of mean. So we test, is it the modification is good or not good? Of course, for certain condition it good, for certain condition it's poor. It's okay. It's okay. At least we can show at what condition the modification one is performed. Okay, so we don't expect 100%. What we suggest, what we propose would be better and the best one lah. The outperform, no. Okay, we always put some humble that for certain case this modification better, at certain case the original one is better. Okay, all right. So doing research is very what we call very beautiful, very beautiful. Okay, because the finding will make you inspired to do more and more. But sometimes it inspire you to stop and stop. Okay, it depends. Okay, hopefully you can meet a good supervisor. Okay, when you pair with good supervisor, when you pair with good surrounding, your friends with positive mind, usually you can face it easily. But if you cannot collaborate with your supervisor very well, and then you are in the circle, negative circle, in negative vibes, of course you cannot finish whatever you want to do. Doesn't matter in research, doesn't matter in our life. So we have to move out from negative vibe into positive vibe. Find out your friends that can help you to be success together. All right, we have a choice, so we choose to be success. Please don't choose to be fail. If you choose to be fail, please feel kasihan pada ibu bapaknya, ya, kasihan. Okay, feel guilty with our parents because they provide us with a lot of money, provide us with a lot of love. Okay, they want you to be success, they want you to be someone very good, to be someone very dominant, prominent, right? So of course we try to be the best. Okay, all right. So this is the whole presentation that I want to share with you. Okay, but before that I want to share with you, maybe you already know, do you know about ChatGPT? Do you know about ChatGPT? Okay, who know about ChatGPT? Okay, can you reply my meeting in the chat room? ChatGPT, nowadays very trending, right? But be careful. All right, I want to show you the ChatGPT. Okay, so yeah. Where are you? ChatGPT. Saya ya, mana ya tadi? Alamak, hilang lah. Oh, where are you, ChatGPT? Oh, here. All right, I already pinned. Okay, you can see my ChatGPT is a AI, artificial intelligence. All right. You can start from Wikipedia. You can read from Wikipedia the benefit of ChatGPT. All right. So you can see, okay, here maybe it's blur. All right. This is the chat. Somewhere my cursor here, you can write a chat message to the admin. Okay. You can see, okay. What is outlier? Right. And then you enter. All right. Okay. Okay, wait. Maybe I have to log again. Okay. Okay. See how beautiful is the technologies. So be careful as a supervisor. We we will face with a challenging work from the students. Okay, but be careful also because ChatGPT also give incorrect definition sometimes. All right, so it means that even ChatGPT will help you, okay, but it doesn't guarantee you 100% perfect true. Okay, so see, what is outlier? An outlier is an observation in data set lies and abnormal distance from other values in data set. In other words, it is a value that is significantly different from the other value in a sample. See how good the explanation compared to me. ChatGPT show that he's very intelligent compared to me. Outliers can have a big impact on the mean and standard deviation of data set, and they may indicate a problem with the data, such as measurement error or difference in population. Outliers can be detected through various statistical techniques, and such as the use of box plot, the Z-score method, and the modified blah, blah, blah. Okay, it is important to identify the outlier. Okay, if you want to know how to handle the outlier, okay, so they will answer you. Very crazy, right? This is the technology, free, no need to pay, but you can pay lah to upgrade to the plus. But for me to get some idea, no need to upgrade, just for the one. But there will be challenging in postgraduate study now. All right, it seems that students know what they do, but maybe they just copy and paste. All right, to supervisor, we have to be strong enough. Okay, but for a student, actually, this will be benefit for you because at least they can give you some information. Okay, see, there are several methods to handle outlier in data set, and the choice of method depends on the nature of the data and the goal of analysis. Dia kata one is first remove the outlier, second trim the outlier, and then third windsorize the outlier, and then fourth maybe you impute the outlier, or fifth maybe you transform the data. This is among the methods suggested when we have the outlier in the data. All right, so that's all from me. Okay.
Okay, thank you very much, Professor Sham.
Yeah.
Well, we actually learned a lot from you about outliers today, and I want to open the Q&A discussion for all the participants in here. Jadi silakan saya buka sesi pertanyaan ya, Q&A session. Silakan yang mau bertanya. Ada yang mau bertanya? Oke, kalau tidak ada yang mau bertanya, maka akan saya lihat partisipannya di sini siapa saja ya.
Boleh saya nanya, bisa?
Oh iya, silakan Pak Sul.
Oke, terima kasih. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Terima kasih Prof atas lecture-nya. Very good presentation. I have two questions about outlier. We know that we live in imperfect world, and that means there always outlier in our daily life. If we consider any abnormal data as outlier, then we have to take care more effort in analysis. Can we take semacam cut point lah gitu, Prof?
Yeah.
Berapa persen misalnya boleh, we can take this is outlier because it is more than for example 10 or 20% macam itulah, Prof.
Tidak juga. That's why we have to perform for univariate outlier. We just perform the Z-score or we just put the box plot. Then they will give you the what we call maximum and minimum value will be changed, depends on the data. So it's something like a control chart. It's something like control chart. So the upper limit, the lower limit will be changed, depends on the data. There we cannot say the percentage unless we want to use the Windsorization. Windsorization, yes, they said percentage can be 10%, can be 5%. But if let's say the data is no outlier, why we have to remove? So we have to ensure that the data having outlier first. Otherwise, no need to remove anything.
Oke, kalau macam itu kan every data usually there is outlier in our data because there is no perfect data lah, Prof, macam itu.
Begini ya. Alright, okay, so depends we cannot say how many percent what we call one standard value. All right, I cannot say one standard value that is outside this one is outlier. No, okay, it depends on the data set. It depends on the data set. All right, so let's say this one okay, I will calculate the Z score for this one. All right, Z score is this value will be minus with mean and then divide by standard deviation. All right, this value minus with mean, the average. All right, this is the value. Okay, divide by the standard deviation. Oh, sorry. Okay. All right, so you will get this value. Then you drag. Okay, option. All right, so I have to log. Okay, log. So that they will always take. So different data set, different, it will be different value lah. Because different mean, different standard deviation. All right. So based on Z score, all the values should be within plus minus 3.3. If you use Z score, if you use box plot, they will compute for you IQR, interquartile range value. All right. So after we confirm the data having outlier, then we can remove it or remain that's all. Okay. All right. Thank you.
Okay, thank you, Prof. One more question, Prof.
Yeah, please.
I've read about I'm not sure about the masking effect in multivariate data. In one dimension, it is easy to see whether there is outlier in our data by plotting using box plot or just histogram.
Masking. Do you want to know whether the data have masking effect or no masking effect, isn't it?
No, I want to. Can you give explanation about the masking effect about masking effect outlier?
What is masking effect, isn't it?
Yeah. What is the masking effect in multivariate data? That's my question.
Okay, so masking effect is the effect that we will face when we have the outlier in the data, right? The effect that we will face when we have the outlier in the data. But what is it? Okay. Okay, like this, Okay, so let's say the example is there is about one variable, we influence another one variable. How to explain in simple way? Wait. Oh, okay. Let's say a song, a song. You can sing a song, right? Okay. So when they pick to the high note, that is masking effect. All right, that is outlier. But what is masking? When it's very loud, there will be masking. It's look like apa ya kalau bahasa analoginya, in situation which one must affect the another variable.
Masking itu macam apa ya? Tertutupi bukan Prof ya?
Yeah.
Covered by some other macam itu kan?
I cannot explain to you in bahasa. Kalau masking effect in sound ya, kalau apa ya? Apa ya? They have two, either masking or swamping. Have you learned about swamping effect?
Tak, Prof. Tak.
Yeah. Later you will. Okay. When you read a lot of paper in robust statistic, okay, when you're talking about the estimator, okay, you will see the word masking effect, swamping effect. Okay. So what you ask me is about masking effect. Masking effect is becomes in about the louder value. Okay. What else? In general, how to make it easy to understand. Oh, like this. Okay. Let's say you want to study about CGPA, right? You pointer in exam, what you call CGPA, cumulative grade point average, isn't it?
Yeah.
Yeah.
Indeks prestasi kumulatif.
Yeah, CGPA. Yeah. CGPA maybe will influence by study hours. More you study, the higher your CGPA. More you study, high CGPA will increase. So it positive, right? But suddenly in study hours, there is outlier. Okay. Suddenly in the study hours, they have some outliers. They may be extremely study hours or very low study hours. Either maybe they just study 1 hour, they can get the CGPA 4 flat, or maybe they just study up to 15 hours, they get 4 flat also. That will be outlier. So that value will influence the CGPA. That is one thing. Okay. Later you can contact me via WhatsApp. I will show you what is masking effect. Okay, you can WhatsApp me.
Terima kasih, Prof.
Sama-sama. Mungkin penjelasan saya kurang bagus. Because sometimes when we learn a lot of technical, then we want to explain more in layman without technical. It's very difficult for me. Sorry. Okay.
Ya. Betul. Saya pernah dengar juga bahwa kalau misalnya kita terlalu mudah, it's too simple to explain something, then it will be much more difficult to, like translate technical.
That is a challenging for me as well as a lecturer, because sometimes we so focus on technical formulation, then we want to explain in layman, what do I mean, and low, so it's very difficult. So but good question for me, at least I know that I have to try to explain in more less example lah. I mean very simple example suppose. Okay, thank you.
Thank you very much, Prof. Syam. Terima kasih juga atas Pak Sul atas pertanyaannya. Dan ini di chat ada yang ingin bertanya, ya, Winda.
Iya, Ibu.
Baik, silahkan Winda bertanya langsung saja.
Ya, sebelumnya Assalamualaikum warahmatullahi wabarakatuh. Hi, Prof. Sam. My name is Winda, and I want to ask you, if I have a lot of data, for example, like 1 billion data or big data, what method are suitable to detect the outlier?
If you have what data?
A lot of data, like big data, maybe.
Big data.
Yes.
Okay. If not interrelated, you can use Z-score, just enough. Box plot is also enough. Very simple one. But if your data is multivariate data, interrelated to each other, okay, you have to understand your data first lah, whether the data variable by variable interrelated or not. If the nature of the data interrelated to each other, so the best is multivariate outlier lah. One of that is Mahalana Resistant. One of that.
Oke, Winda, bagaimana atas jawabannya?
Iya Ibu, thank you Prof. Sep.
Ya.
Ya, jadi tadi untuk semuanya ya, selain Winda juga, misalnya tadi itu kalau misalnya kalian punya datanya hanya satu variabel yang tidak berhubungan, kalian bisa pakai z-score, dan ataupun kalian punya yang berhubungan, ya, jadi nanti pakai multivariat, artinya pakai Mahalana Resistant, gitu ya, jarak Mahalana Resistant kalau kalian belajar mungkin di vektor ya. Oke, selanjutnya ada lagi yang mau bertanya.
And then usually when we want to become a consultant, okay, if people usually non-statistician, okay, or non-academic, maybe from agencies, from NGO, they will come to us and then will ask us to analyze the data. Okay, it will be okay if they ask us to analyze the data. But if they analyze already, but they come to us, usually they did maybe they hope that the t-test will be p-value smaller than alpha, significant, but they get not significant. Or maybe they Cronschbach alpha when they're supposed to get value 0.7 and above, but they didn't get 0.7 and above. Okay, so they will come to us. Usually they will do first, then they come to us when they have a problem. Okay, so one of that is outlier. Okay, you check the data, you remove the outlier, you run again. Usually it will help you to improvise the value. Instead of significant and not significant, it can be significant. Instead of Cronschbach alpha more less than 0.7, it can be more. But not only one, the outlier, there can be so many things. Okay, you can learn data screening. Okay, books by Tabachnik and Fiedel. If I'm not mistaken, multivariate statistic or multivariate method, something like that. If you Google, you can find that. It's a very famous one. Data screening by Tabachnik and Fiedel, multivariate analysis or multivariate methods. Okay, and that's the core, what we call the G's of a consultant supposed to be, because people will come to us for asking why this one happened, why not. It can be significant. Why this value? Why this value? Okay. But if they come to me, okay, please do the analysis. It's okay because we know how to handle the outlier, how to handle the missing value. Then we calculate the for them, right? But usually they will come for consultation. That you can make money from that. Then you can make money for that because let's say for the government. They have the grant, right? They have the grant. Okay, I'm not sure. I think Indonesia is much better than Malaysia in terms of providing the grant funding. Okay, funding for the industries, for the student project, everything. Okay, you find out some industries have the funding for the students.
Okay, interesting. Okay, ada lagi yang mau ditanyakan? Ayo, mumpung ada Prof. Syam di sini, jadi kalian bisa langsung.
Maybe for your final project, because everybody is undergraduate student ya Ibu.
Yes, ya, betul. Jadi kalau misalnya masih ada yang bingung dengan topik skripsi, ya, topik apa namanya? Inilah ya tugas akhir, topik tugas akhir tentang outlier ini bisa dihubungi nih Prof. Syam, atau misalnya kalian punya pertanyaan, misalnya pengen mendalami outlier itu bisa. Nah, mungkin kalau belum ada yang bertanya, boleh saya bertanya, Prof?
Ya, boleh. Yang mana saya tahu jawab semua.
Ya, jadi tadi saya lihat ada satu paper di sini yang Prof tadi sudah mention ya before, itu paper robust regression by means of S estimators. Itu paper number 3 from Rousseau and V. Yohai. I actually want to ask, what is the estimators? I just yeah, I seen this I saw this, and then I was yeah, I want to know more about what is the
Gini
estimators.
ya. Mean, okay, mean X bar, right? We call it mean. Okay, the symbol is X bar, right?
Yeah.
X bar
Yeah.
is estimator. Standard
Yeah.
deviation, we call it S, small letter S. Variance S squared, that is also estimator. Okay.
Okay.
So mean, if you learn more in robust, okay, any estimator replace the mean, they call it location estimator. Okay, if you found, okay, when you read location estimator, actually is refer to mean, median, that is location. Okay, and then standard deviation, they call it scale estimator. SCALE, scale estimator. Yeah. All right. So when you learn robust, there are so many estimators that introduced by them for location and for scale estimator. All right. S estimator is one estimator for location. All right. Where this that is what we call equal to mean. The function is equal to mean. All right.
Okay. So it can be used in any regression or any modeling?
Can be used in?
Yeah, it can be used in any regression model or
yes.
any other modeling.
Okay, you
regression.
go through again the formula. Anything in the formula having mean X bar in the formula, you can replace it by S.
Replace it with S estimators.
Yeah, maybe discriminant analysis, right? Discriminant analysis having the mean.
Yeah.
Yeah, X bar, discriminant, what we call the X bar as inverse, right?
Yes.
Hoteling also S bar as inverse, and then Mahalana Resistant S bar and inverse, and then t-test ada X bar, ada S, standard deviation. ANOVA also in the formula X bar mean, right? Yeah. The calculation of between treatment, within treatment is involved with me. Yeah, of course you can improve. You can use the S estimator instead of mean.
Oh, so it just replace the meanings.
Yeah, just replace the
robust.
Yeah,
So
and then you see what
outliers.
happen. Yeah.
Okay.
So that's why I said robust statistic is less challenging in terms of in terms of using lah. But at least for FYP about final year project, you can start with replace. And then after you make some replacement for the master project, maybe you improve the scale, the estimator. Right. Or maybe you improve in terms of algorithm computational to make it more faster in terms of time, computing time. Maybe S estimator also what we call very complicated. Very complicated, not as easy as X bar. But geometric median easy. Certain estimator complicated, certain estimator easy. So maybe you can make a comparison in terms of time consuming for the computation. So that can be one project, right? For small project.
Yeah.
Computational efficiency between geometric median, S estimator, M estimator. So after you compute computation, which one perform? Then you take that one, put inside the t-test. Then you compare the original t-test and the modified t-test. So how to compare? By using type 1 error. Because the type 1 error is the value lah, and maybe power of test.
Okay. So it's related to each other.
You can get the idea, right?
Yeah. The idea is so simple, but actually we already applied it to the real life. it's still fuzzy.
Yeah, lah, of
A
course,
little
lah,
bit,
of course.
because we cannot see once and then as you said, we cannot see once and then understand everything.
So the data, something like financial study, stock market, they will have a lot of outlier data.
Yes, of course.
Yeah, because they're involved with fluctuation, right? Compared to social science studies. Social science studies survey, there is no outlier usually because we put them, okay, from 1 to 10, from 1 to 5, from 1 to 7, because we specific. But if let's say data, open data, financial data, stock market, GDP, unemployment rate, let's say, okay.
Yeah. Okay. Yeah, I've already seen a lot of outliers in my life.
Yeah.
Yeah, because I am focusing on econometric
image processing. One of the researcher in Indonesia, Dr. Dia Tarumanegara. Tarumanegara, ada kan? Jakarta. Dr. Dia, she is one of Dr. Swanda jugalah. We share a same supervisor. Okay, she works a lot in remote sensing data on how to detect the outlier. Okay, let's say we take the picture from the satellite, the forest, for example.
Yeah.
Okay, then we of course lah, you have to learn Python lah. Python, how to pronounce. Okay, the programming to transcribe from the picture into the data. Then we remove the outlier using Mahalana Resistant. Then we transfer again into picture, and then we can see the different picture.
Okay. I see.
Okay.
Wow, that's very interesting.
Image processing.
Image processing. Yes. Oh, okay. Yeah, there will be another topic for
I'm still
final project. Yes.
Yeah, of course. But you have to learn how to transform from the image into the data.
Yes.
Once we have the data, we can calculate, right? The problem now from the image to the data. For those who are loving the programming language, you can do that.
Yes, definitely. Yeah. Sangat menarik ya, Prof ya. Banyak hal yang harus di-explore.
Saya pun belum mencubanya. Saya pun belum mencuba. Saya cuma belajar daripada Prof Dia, Ibu Dia, what we call picture daripada image bunga. Flower image, using MATLAB. MATLAB can read, but not remote sensing image lah. Only the flower image, very simple image, and then how to transfer the data into MATLAB. MATLAB know how to do that. They will read into RGB. RGB. No, the colors RGB.
Yeah, I know. Yes, RGB. Yes.
Yeah, yes.
Okay. I see. Wah.
Yeah.
There are so many outliers team, outliers team project topic ya, Oke, kalau gitu ada pertanyaan lagi dari peserta, silakan mahasiswa, mangga, Bapak Ibu dosen atau Pak Aceh mungkin ada pertanyaan lagi.
Ya, masing-masing still learning, right? Still learning.
Yeah.
Okay.
Of course, yes.
So of course. Okay, but from the outlier, it can be from undergraduate level, master level, PhD level, from the same topic, but the different focus, we compare different thing, we modify different thing, it can be different level. So that's why I said I have to share this topic because this topic can be what we call suitable for any level.
Okay. So what do you say about probably the topic we have already covered, like some of the topic for outliers for undergraduate degree and then for master degree. Also, how about PhD degree? What kind of topic in outliers that can be a PhD topic degree?
A PhD topic usually we will modify lah. We will modify the statistic, the existing statistics, all right, with some estimator, all right. But for me, usually I will combine with the problem with high dimension, two problems. Okay, first
okay.
outlier, second, how about the small sample size? Because not everything can having a large sample size.
Yes, because nowadays if we
Yeah.
have outliers
So usually I will
and
combine these two problems together, and then it become PhD level. For me, if only consider one thing, all right, by just replace cannot be PhD level. Okay, maybe some comparison, thorough comparison can be master level.
Okay, so how do you actually modify the sample, the small sample size? What can you do with small sample size? Okay, let's say
That one we have to play around with. That one we have to play around with algebra.
Oh, okay.
Algebra. That one the work by Pak Wanda, vector variance. Okay. Once developed by Pak Wanda is vector variance. Dr. Diah if MVV. What vector variance? Minimum vector variance, if I'm not mistaken.
Oh, minimum vector variance, yes.
The extension, the improvisation of Pak Wanda is Dr. Diah. Okay. My case is on the algebra, the element ada something more on algebra. Let's say for covariant, we have similar, right? The upper diagonal, lower diagonal similar, right? So I will remove the upper part, only the lower part I consider. That is the way we want to solve the problem of singularity. That's my work.
Okay.
Similar to work by Erna, one of us, Maman students also, Erna, from Indonesia as well. I cannot remember Erna behind, Erna what, okay?
Okay, I see. Thank you, Prof. Shah, for answering my questions. Yeah.
My supervisor from Indonesia, so of course, I have a lot of Indonesia reference lah.
Yeah, that's really good. Oh my God. Okay. Ada lagi yang mau bertanya di sini kira-kira? Sudah tidak ada. Baiklah, Pak Aceh, bagaimana Pak Aceh? Ada pertanyaan dari Pak Aceh?
Ditutup saja, Bu Ica.
Oke, baiklah kalau begitu. Baik, Prof. Syam, thank you so much for having your time with us, sitting with us today, and then talk about outliers. We already talked about, well, I guess many things about outliers, robust method, and then also there are a lot of estimators that you mentioned before, and also there are a lot of branch of topics that you can go from outliers and then to another topics as well. And there are different levels, of course, for the topic from the bachelor degree to master degree and to PhD degree. They have different same stance, but different work, different way of work, of course. And then, Alhamdulillah, we are coming to the end of our lecture. Thank you to our speaker, Professor Syamsuritawati Sharif, and thank you to all the participants who are eager to gain knowledge from this webinar or from this lecture. And I will also want to apologize if there are any mistakes in my speech. At last, thank you all for helping support the next generation of innovators. We have an excellent event with all of you, and we look forward to seeing you in the next lecture. Let's go. Let's close our agenda by reciting Hamdalah, Alhamdulillahirabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Terima kasih semua.
Yeah, thank you.
Terima kasih, Prof.
Sama-sama ya Pak Aceh ya.
Terima kasih,
Kirim salam sama Pak Wanda.
Oh ya, baik.
Baik.
Saya sampaikan.
Ya.
Oke, dan untuk partisipan semua jangan lupa untuk absen ya. Sudah ada absennya di chat, jadi jangan lupa untuk di absen. Saya undur diri, saya pamit dulu Pak Aceh dan semuanya. Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Terima kasih, Bu Ica.
Ya, sama-sama Bapak.
Izin, Assalamualaikum.